Okay, thank you so much for inviting me again for this workshop. So actually, this is the second day of the workshop. So in yesterday workshop, what we have discussed, actually, we have looked at the prospect maturation. So there is a lot of things which we have discussed in yesterday. So if you have missed it, so you can have a look on this the previous workshop recording like that. So this workshop is again as mentioned that we have this workshop because of the course we will be offering in next year. So this is the second part of that. So in the first day we discuss about the prospect maturation, and we learn about the basic of the prospect. So what type of prospect we have, how many types we have, and what is actually the prospect. And also we have differentiated the prospect with the lead, and also understand more about the some other stuff related to the AI. And also I have given some introduction about the machine learning and artificial intelligence, how we going to utilize in our prospect maturation. So generally speaking, that let's say if we are talking about workflow about the prospect maturation using AI, so there is no specific workflow for using any workflow, because prospect maturation is not a very simple stuff. You just give the input data and you process it and you get the output. So we have to look a lot of things, like I have discussed about we have to do the basin analysis, then we have this seismic interpretation, then attributes analysis, seismic inversion, AV analysis. So these are complex stuff. So in each of these, when we are applying, so we will be using like the machine learning stuff. So if possible, some of the places we will be using coding, and some places like some attributes, some automatic interpretation or stuff. So we will be using some of the AI stuff. How to use that AI stuff in the software or in the coding, that is the main task for us to understand. So let's start for today. The workshop. So let's look at the. So today I'm going to, discuss some of the AVO stuff. So the first topic which we are going to cover is AVO. So AVO stands for amplitude versus offset. So this is one of the good part in prospect maturation. So let's look and understand about the AVO and how it can uh, help to identify the prospect. Okay, so let's understand the AVO. What is AVO? As I mentioned, AVO is the amplitude versus offset. So, and actually it is a primarily variation in the seismic reflection. So there is a lot of seismic you have been looking at. So what are these seismic? So mostly we are looking at the different seismic data. Let's say normally when you are doing the interpretation, so you are looking at the full stack, or sometime it is on a different angle stacks. Let's say it's a near offset or far offset or mid offset. So that is the also the objective in prospect maturation. It can help us to identify different type of prospects. So we are going to discuss that one. So first understand that what is AVO. So the AVO is amplitude variation with offset. And also it represents the seismic reflection amplitude with change in the distance between shot point and the receiver point. And it is another name of AVA, which is normally used in the industry. So which is amplitude variation with angle. So either with offset or either with angle. So I'm going to explain what is offset and what is angle. And it also, the beauty of the AVO is that it can physically explain the presence of the hydrocarbon in the reservoir. And also you can have a understanding using AVO, the thickness of the reservoir, the porosity of the, your reservoir rock, the density, velocity, lithology, and the fluid contact of the reservoir of the rock, and it can be estimated using AVO. Okay, so let's look at if I understand, because this workshop is a very basic, so I just introduce as well. each topic. So let's understand the offset. What is offset when we are referring most of the time? So offset is actually in when we are doing the seismic acquisition. So we have number of source and we have number of receiver here. So the distance between this source and this receiver is your actually offset. So in this case, I'm showing one of receiver. So let's say if you have two receiver, three, and so on, you have multiple receiver. So the offset will be changing. Let's say this one be considered as a near. Then if you go for this one, let's say you have 100 of receiver, then this is a far offset. So that is actually the term which we use normally in the offset. And also in a vertical seismic profile like VSP, the offset is actually the horizontal distance. So normally in a vertical seismic, we are doing in the borehole. So we have the shot here on the surface and we have the receiver toward here in the well. So in that case, the offset is the horizontal distance between the source. So in this, we have the offset in vertical seismic profile. In different cases, we have these type of things as well. So how we can also another term which we use, the angle stack. So that is about the offset, which we have looked at before. So now we look at the angle stack. So in angle stack, actually, it is based on the AVO information of the seismic data. And also they are usually designed to measure the reflectivity at a given incident angle. But the term angle stacks can also be applied to the general combination of intercept and gradient. So if you look at this formula, we can have based on this formula, so we can find out the different angle of the seismic. So in here, you can see these terms. So this is a very simple formula which we can apply to have the angle offset of our seismic data rather than the angle stack rather than the offset. Let's look at more about the angle stack. So in here, we can see in this figure, so on x-axis, we have the offset and y-axis, we have two-way time. So in that case, normally how we do the division of the offset or the angle stack. So in that, you can see this is actually the angle mute we can do. So let's say when we draw this curve, so which is the first one, it is actually the 15-degree curve, and this is your 30-degree curve, and the rest is above 30 degree. So in that case, what we can say, this is near, this is mid, and this is far stack. But in some industry, in industry, actually, we use multiple offset stack. So it's not based on only the 15-degree, 30, and above 30, but you can divide it to 5-degree, 10-degree, and also some other degrees you want. So that is also normally used for more detailed study. So in that case, on the right side, this is actually the real seismic. So based on that, when we have this offset and you have the two-way time, so we can divide these angle stacks into different, obviously it has to go like NMO corrections first, then it will going to be having the other stuff like, then we can just only do the angle stacks for this type of seismic. So why actually we are doing this angle stack? So angle stack is very important because when we are doing the prospect maturation, so we are looking at the hydrocarbon, so we have to find out the reservoir. So reservoir is one of the main target which actually shows the prospect. So this is an example of this AVO. AVO actually gave you a sand indicator. So in this case, we are using two models. So in that case, we have hard shale and we have the soft shale. And in that case, we have the hard shale and below is the sand. So in both cases, when we develop or we on this both model, if we look at the AVO response, so over here you can see, so this is your near, this is your near offset, then it's going into the far, in this way. And in that way also it's going like that. So if you look at this figure, this angle, in this angle, you can see this is the high amplitude, then on this side is going to be a small amplitude. So if you go this way, your amplitude is decreasing. So that is in case of hard shale over soft shale. But let's say, which is actually normal case, we have the reservoir. So because this is lithology indicator and this is your reservoir indicator. But in this case, you can see this side you have the low amplitude, but over here the amplitude rise. So it means whenever you are looking at some different angle of the seismic in the data, then you can find out the sand, which is normally you have the reservoir in that area. So in that way, AVO can give you the brightest spot. So normally what happens, so when you have the lithology indicator, lithology difference, then you have the low amplitude contrast. Or even in near angle, it's different, but far angle, it's become low. So, but in reservoir prediction, you can use this AVO as a indicator of your sand or your reservoir. So that is also one of the beauty of the AVO, which actually give you the indication of the hydrocarbon reservoir. So that is one of the objective we use also AVO analysis for prospect maturation. So this is an example. So in that case, actually in this case study, so this have been changed to different angles. So as I mentioned, so we are not just having the near, mid, far. So here we have the near, mid, far, and also the ultra far. So in that, it has divided into different degree, like 6 to 10 degree, 16 to 26, then 26 to 36, and other than and above the 36. So normally your angle is not more than 50 degrees. So in that case, actually the objective of showing here, so you can see different angles, like in this case, and far angle shows the bright amplitude. So this is actually your sand reservoir over here. In lower, it doesn't. So we have to verify in different angles or angle stacks that how the seismic is behaving. So if you look at the top, I mean, let's say in this part, so you can see here, it's not rising over here, even it's going small and small. But when there is a sand reservoir, so in that case, you can see this is a rising AVO. So that is one of the beauty of the AVO analysis, which can shows you the prediction of the hydrocarbon or the sand reservoir. So that is one of the things which we are going to use for prospect maturation. And this is also another beautiful example. So over here, you can see there's two angle stacks, which is on the top is near angle. So this one is near and this is far. And this is actually the difference between near minus far minus near. Just to verify there is some difference or there is an amplitude rise or not. So over here you can see from this blue box, you can see the indicator of the window where the background trend is estimated. I mean, this background trend. So this minus this, so it's still there is some amplitude. So it means there is a rising AVO. And this one actually, which is already verified from the well, so which is the yellow ellipse, you can see here the gradient anomaly of the gas and oil discovery of this well, which is well 1. And also this one red, which is showing here. So this is best indicator of the oil discovery as well. So this is not, I mean, drilled, but it's a possible prospect for this area. So that is also one of the application which normally use in the industry. So we are also going to use in our course for prospect maturation. So that is actually the beauty of the course, that we will be using multiple technologies and different methodologies in prospect maturation. Because as mentioned in the last workshop, I mean the first day of the workshop, so when you suggest a drilling point to the drillers, So actually the cost of the drilling is a lot. I mean, so at least before you give a wrong decision, you have to verify from the multiple methods, because applying these methods will not cost a lot. But when you ask to drill the well, if the well is not successful, then you will be we have a big loss. So that's why even if we have to go for reacquisition, so let's say in some area you don't have like near mid far stack, so some of the processing centers even go for the reprocessing of the data to have this multiple stacks like near mid far, so that can help. And sometime even if you don't have the data, so you go for acquiring new data for high resolution. So if you think that this prospect is available but still there is a flaws in the data, then you can verify from seismic inversion, from AVO analysis, you can do from reservoir studies, rock physics analysis if you have some sort of these studies. So that is a way how we do the prospect maturation. So the another beauty of this AVO analysis is actually it is also indicate the fluid. Fluid mean either it's oil, gas, or the brine. So that is also one of the beauty of AVO analysis. So in this case, we are showing the model of two-layer models, which is actually hard shale over soft shale. Either we have the brine, or we have the gas sand, or we have the oil sand. So in this case, we are taking like this one is actually the hard shale on brine sand. Then the second model is hard shale over oil sand. And the third model, which we have taken here, is a hard shale on gas sand. So how the AVO will behave, like amplitude variation with offset. So when we look at these models, so actually this AVO analysis also can differentiate the either it's a oil, either it's a brine, or either it's a gas sand. So if you look at this graph, I mean this AVO graph, so you can see from here to here, the amplitude is rising. But in case of brine, your amplitude rise is not at the higher level. But over here, if it is an oil sand, then you can see the amplitude from this place to this place, it's rising and it's moderate rising. But if you have the gas sand over hard shale, because we have studied that the shale is actually your cap rock and gas sand is actually your reservoir rock. So let's say if you find this type of rocks, like you have the shale, then you have the sandstone. So it means you have the reservoir rock and you have the cap rock. So if in that reservoir, either you have brine or either you have oil or either you have gas. So that is a verification of AVO method. So AVO can verify either it's a gas sand, brine sand, or it's a oil sand. So what is the summary of this one? So if let's look at this third one. So if we have this gas sand, then you can see the rising AVO is a lot. So if you look at the summary over here, so the brine sand looks like this one, oil sand has this signature, then the gas sand has the higher amplitude variation with offset. You got it? Okay, so in that case, if we look at the summary, so if you have the high, high variation in the amplitude, then you will go for the gas discovery. Or if you have the moderate one, then you can suggest this is the oil. And if you have a low, rising in AVO, so probably it's a brine sand. Brine sand is a wet sand, so there is no hydrocarbon. So that is also one of the use of the AVO analysis for hydrocarbon prediction. So this is a good example, and actually it's a class 2 AVO, and we will learn also from in the course about the classes. So how many classes we have. So this is one of the class which is class 2 AVO. So over here you can see there is a lot. This is a seismic section from one of the field in Malaysian region. But you can see here, So these data and this data, you cannot differentiate which type of, where is your reservoir, but actually we have the drill point here. So that's why you can know that the reservoir is here. But when you look at this near offset and if you have this far offset, so you can see the difference actually. So this is actually the rising AVO, and you have two reservoir potential. So this is the first reservoir, and this can be the second reservoir. So this is a very beautiful example which have been actually explored, and the AVO have shown a very bright amplitude increase with offset. So probably this is a gas reservoir. So that's why we have very bright amplitude increase in this case. Okay, so now we look at actually the prospect maturations comes in at which place. So you will be thinking that we are wandering from one method to another method, but actually we have to look at where does the prospect maturations comes in our oil and gas industry. So normally that is called the life of field. So what is the life of field? Actually, it starts from acquisition, then it goes to exploration, then goes for development, then production, then abandonment. So this is actually the journey of life of field, or we can call it. So in acquisition, we have multiple tasks. I'm not going into detail because the acquisition is not our interest topic for prospect maturation, but obviously it is very important. Then in exploration phase, in exploration, we have multiple tasks, like you will having the develop prospect model, like the prospect maturation, which is the part of execution exploration plan. In that, actually you have come up with the regional models and also the exploration drilling point. But obviously it has to go through the prospect maturation. So let's look at this part in more detail in the next slide. So when we look at the only the prospect maturation part, how we have to contribute in the prospect maturation. So over here you can see the prospect model is actually depending on the data acquisition, data processing, you have interpretation analysis, you have the prospect model, you have the rank prospect, as well as the another like exploration drilling points. So these are some of the stuff that we have to look when we are looking at the prospect maturation. So nothing is, I mean, in unnecessary, but everything gives some values to the prospect maturation. Okay, so that was about some about the life of field. Now we look at the basin analysis. So when we are talking about basin evaluation or the exploration life cycle, so that actually starts from the basin studies. So basin studies are normally have been done regionally, so it can be all over the world. I mean, you have multiple basin, then you have to differentiate what type of sedimentary basin you are looking for. Then you go for exploration purpose. So exploration means you have the acquisition, processing. So actually the prospect maturations comes in exploration part. Then further prospect, when you have find it out, then it goes for development, production, and abandonment. So that is not the part of prospect maturation, because we should also have to be very sure where we are and where we have to work and what is our target. So what is the critical role? So geoscientists at exploration and development stages. So especially when we are going for basin evaluation, the prospect maturation, and also the exploration, the appraisal, well drilling. So that is the main part of the prospect maturation when we are looking for. So if we look at the world sedimentary basin, so from the regional case studies or regional geological studies, you can get the sedimentary structure of the basin. So here is one of the example. So you can see this, the orange color, like here, it shows the deep waters basin. Then the green, which is normally at the shelf. So over here, if you look at, this is the part of, yeah, it's Malaysia or somewhere. Then we have this Indian Ocean and this part. So that is actually the shallow water we have, then we have the shallow water onshore as well, and the cratonic area, so which is most of the region we have for exploration of oil and gas. So there have been question about the workflows. So how actually we do the work? I mean, how actually we do the work for prospect maturation? So as I mentioned, there is not a specific workflow for going all the way from everything to the prospect maturation, but we have multiple workflows that combines and come to the prospect maturation. So when we are specifically talking about the play-based exploration, so we actually come up with multiple studies. So because when we see anything in triangle, so actually we are coming from big things, then we are narrowing down to the specific topic. So the objective is here to the prospect maturation or the prospect focus, but actually we start from different type of studies, like you have sequence stratigraphy. In basin studies, you actually go for petroleum system, 4D analysis. So these are the things actually we have to come up for prospect maturation. Then once the basin is done, then you come to the play. Let's say you already done the basin studies, you find out the petroleum system. So now you have to look at the play. Either the play is available or not. Then to verify this play, actually you have to do the seismic imaging stuff, geophysical attributes, geological modeling. Then based on that, I mean, let's say these method also verify that your play is successful. Then you have to find out the maturity, the risks, uncertainties. Like either this play is important, but either it's beneficial for you or not. Then you have to come up these type of studies. Then prospect portfolio, and portfolio, actually it's a summary of everything which we have done. Either the potential is mature and also it is economically available. Then normally you go for drilling point for this purpose. So that is actually the whole story of this play-based exploration. If you look at the good geology and also the what is the workflow. So normally it starts from the basin assessment, which is the first process. This stuff I have explained in the previous one. Once you have the prospect, then you do the assessment of the prospect. Then you go for play the prospectivity calculations. Then if this prospect is the opportunity, then you go for drilling. Otherwise, you will just skip or you just left the area. So that is a general, I mean, workflow which we normally use for um, general geological workflow of the prospect maturation. Another thing, when actually the basin analysis, which is very important for prospect maturation. So when we are doing the basin workflows or the basin studies, then most of the time we follow some workflows. So in basin analysis, normally we come up with three main categories. So one is the regional geology of the area or the basin setting. Then second is a sequence stratigraphy, the framework, either from which we can do that. And also the third thing in basin studies are the petroleum system. So these are mainly belongs to the basin analysis. So when you are a geophysicist working in the industry, mostly you are aware of these things, but if let's say you are new, then you have to know that what is your part and what is the other part, like geologists, geophysicists, geoscientists, what they are doing in the basin analysis and then in the prospect maturation or like that. So normally the regional studies, as I mentioned before, so it can be like tectonic history, structural, the fracture, seal, overpressure of the basin. Then the sequence analysis, normally you do the seismic studies, seismic survey will be done, then you only know the stratigraphy or structural interpretation of the seismic data. Then you have the well biostratigraphy correlation. Then you have the fishes distribution, like what type of lithologies we have in the basin. Then you finally come up with the sedimentary model. And in petroleum system is very straightforward. So you have to look at the hydrocarbon types, then either your source reservoir uh, is correlating each other or not, because sometimes you have the source but your reservoir is not there. So that thing you have to come up, and sometimes you have both source and reservoir, but there is no correlation, I mean the connection or the migration stuff. So that one we have to come up with this petroleum system. And finally, then you will look at the migration pathway in the petroleum system as well. So from all these three methods, like the regional setting, sequence stratigraphy, and petroleum system, you will come up with the play and lead ID. So let's say this is not still the prospect, but you will come up with the play or lead. Then you will have again look at the reservoir, source, trap, and timing. So what is the, then you have the risk, volume, volumetric, and ranking of this area. Then after these all stuff, then you will go for drilling prospect. So that's why I told you that we are not specifically having one workflow, but we have multiple workflow to come up with the prospect maturation. And most of the stuff which we will be using, like attribute, we are having some inversion stuff, reservoir analysis. So we'll be using some machine learning stuff to predict that one. Interpretation stuff, these type of things we are looking at. So in prospect analysis, let's summarize this workflow. So in that we have the regional studies, then we have the tectonic framework. If we just pinch out like 9 main points. So we have the sequence stratigraphy and petroleum system plays a crucial role. Then obviously based on that, we'll come up the volume estimation, then risk assessment, like we did in the last figure as well. And also the economic evaluation is also very important. So that everything is perfect, but it's not economically viable, then you will not go for that drilling of that prospect. In base analysis, we have tectonic setting. In tectonic setting, sometimes you don't have the stratigraphic feature, but you have to gather the structural feature in that region. So normally tectonic setting comes up with the structural and stratigraphic setting. Then we come up with the petroleum system. So it's a little bit different from the previous workflow, but you have the structural framework as well. Other stuffs are the same, so we can also use this type of studies, because it depends on the region. Either we are dealing with the structural or stratigraphic traps in the area. When we are doing the basin analysis, so we have to come up with the basin models as well. So the basin models normally come up with this geological information of this this form. So we have to look at the deposition environment and also the other stuff. Then we come up normally the basin models and how the basin was formed and what are the features and structures are there. Now let's look at the petroleum system in more detail. So in petroleum system, actually, we have the hydrocarbon accumulation. Like if we talking about the petroleum system, so there are 4 components. Like in prerequisite, normally we look at the source, reservoir, and seal. Then the process or the maturation of this hydrocarbon is come up with the maturation, migration, and implicit. So the first thing is reservoir. So let's look at the reservoir. So normally the reservoir rocks is actually the hydro. It's normally in the clastic reservoir. In clastic environment, we have the deltic and the shore face sand. So normally these type of reservoir rock is rich in hydrocarbon, as well as it is rich in the fishes and this type of distribution. So this is one of the example, which is actually from Brunei. So this is one of the reservoir rock, which is sandstone. And the carbonate reservoir, sometimes you have carbonate behave as a reservoir. So in this figure, you can see this is the close picture of this part. So this is the hand specimen of the dolomitized. And over here, you can see this is a high porosity. You can see the green, and you have the permeability is also very high in this type of rock. So these also analyses have to be verified in the lab. And also there is not always the reservoir rock is your sedimentary rock, but in some cases we have the basement which behave like a reservoir rock. So what happened that normally you have this type of structure. So let's say your sedimentary basin is like this over here, and you have the oil producing here. You have the source rock, but reservoir is not there. So what happened here? So the oil or gas, it actually migrate to the basement. If the basement is fractured, then it's mean the porosity and permeability become higher. So in that case, we can produce from the basement as well, from the fracture, but it should be fracture basement, and the fracture conductivity should be very high. So we have some example from all over the world. I have a personal experience in some of the basement reservoir, especially in the point of imaging. So we image the fracture to find the connectivity and the porosity and permeability of the reservoir. So in that case, we can also look at the fracture system. If you look at this main fracture reservoir, so normally this is the fractures in the exposed rock. You can see this can become the connectivity and behave like a reservoir. And also some of the reservoir, it can be like unconventional. So you have well known about the shale gas or shale hydrocarbon and coal bed methane. So this also behave like a reservoir. So the second thing is a source rock. So the source is normally the highly total organic carbon, which is TOC material deeply buried in the exposed or the sufficient temperature and pressure hydrocarbon will be generated. So this is an example which is shown here. So this is a shale, which is normally, you see the blackish. So these type of, if you look in the cross section, this figure. So this is like 2 meter thick bed. And over here you can see the carboniferous shale material. So when this rock is actually buried into the subsurface with the best high on the best temperature and pressure, then only it can produce. But just to give you an idea that sometime for prospect maturation, you have to do the geological studies as well to look at the hydrocarbon the organic content of the rock. Then the third one is the seal or the trap. So this can be divided into different form. So the trap and their association as well. So normally if you have the anticline, so anticline is normally known as the fold or the salt dome or the uplift block or the buried hills like sand lands and also different type of structure. The second trap can be fault. So in faulting also you can have like fault can behave like a migration path, or sometimes it behaves like a trap that I have shown in the last example, but I will show you another example as well. Then sometimes you have the up dip wedge out. So that is also one of the stratigraphic feature. The stratigraphic feature, you have multiple like unconformities or disconformities, diagenesis processes. So these are also behave as the trap of the reservoir. And also lens types like sand lens and some salt dome also behave like a traps. So for the example, if you look at, so these traps can be like, this is the first trap which is associated as the fold, which is like anticline. So you can see the oil or gas can be trapped here in that part. And as I mentioned, sometimes it's a fault. So when we have the fault and you have beside the fault, you have this seal rock. So that's why you can, the oil and gas can trap on this side. And the second is stratigraphic trap, like you have geobody like that. Then you have the gas, oil, and water. The fault also, again, So this fault actually behave like a trap as well. So over here you can see the gas, oil, and water. But it should be like the it should be in the in the reservoir rock. And over here you can see the unconformity, and conformity also behave sometime as a trap. So over here you can see this is the older rocks, then this is the deposition new rock, then this behave like a cap rock, then this convert into the trap. Salt dome, like this salt dome, and beside the salt, because salt is unpermeable, so that's why it behave like a cap rock. Then beside these rocks, so it can be, there can be a hydrocarbon trap. And this is like a lens shape, which is sometime happen in the carbonate rock. So what is the good seal? So good seal is normally is a non-porous and also non-permeable. Seal mean that the hydrocarbon has to be sealed, so it cannot propagate to the upper side. Like over here, if you look at this one, so in that case, here is a seal, this is a seal rock, and in that case, this is a seal. So the seal is very important. So it can be like andesite, like evaporite, like we have this salt. Then we have a thick shale or mudstone, argillaceous tight limestone, the cemented conglomerate. So that can be good seal rock. So over here you can see this one, like you have the reservoir, you have the seal. So in this case, we have a shale. So in geological modeling, normally when you are coming up with the static or basin study, so you have to include multiple tasks. Like there is a lot of integration of all geological, geophysical, and petrophysical analysis. Like we have stratigraphic interpretation, the seismic interpretation, geophysical interpretation. Then if you come up with the 3D models, then we come up with the structural interpretation and also the petrophysical interpretation of the data. So geological model contain a lot of information which has all this input coming from geophysical methods. So when you come up with this model, so this looks a beautiful model, but actually you can have a lot of information for porosity, permeability, structural stratigraphy, or some other rock physics analysis as well. So if you look at this one, as mentioned, so each part is sometimes it is not the same rock. So sometimes you have the same formation, but within the formation you have a different component of the other rocks. Like in that case, if we divide this part into different blocks, like when we are doing the machine learning stuff, then we divide each block of the part of the rock into different components based on their porosity, permeability, velocity, density, and everything. So let's say if we divide like 50 meter into 75 meter, so and 1 meter like in the thickness, so we can have different blocks of the rock. So based on that, then we can find, like, let's say in this part, we have sand, shale, shale. But here you have the sand more, but shale is less. So it's 0.1. In that case, probably it's the same one. So like each cell in this part can be populated with the rock and fluid properties. So like we have the fishes information in that area, porosity, permeability, fluid saturation, and everything you can add into your machine. So that is called the digital rock physics model or the rock model. So based on that, you can find out the accurate measurement or you mean the volume of the hydrocarbon which you are targeting. Also, we can use the seismic inversion stuff. So normally the seismic inversion is a beautiful things which can brings up the more information about the subsurface, including like VP, VS, and you have like fishes map or some other stuff. Then finally, once you apply these type of things, then you can come up with the fishes probability using like stochastic inversion, and also you can have the geobody interpretation like that. Then also normally when you done this model, so the velocity is very important. So if the velocity model is perfect, then you can only go for seismic inversion and stuff like that. Then over here, if you look at this one, so this is a workflow. I mean, not really a workflow for petrophysical analysis. So this seismic interpretation using petrophysical log as well. So from here, you can see this is the original seismic, and you can do some condition seismic, like you can increase the resolution of that one to predict the fractures. Like in this case, we have the end tracking cube. So over here, the fracture connectivity, the fracture reservoirs, or the fracture in the reservoir, or either basement, you can predict based on different stuff. So this is one of the machine learning techniques, which in machine learning techniques, you can predict the faults and fracture better way. So that is one of the objective in the course, because we are not using in each part the machine learning. We have to bring we have to come up with a good machine to our brain. I mean, if you can think better to apply specific method at certain position or certain condition, then only you can achieve. So our objective is not to just apply the machine learning in every stage, but we have to look where we need the machine learning action or the artificial intelligence. Because if your intelligence is good enough, then you don't have to go for machine learning stuff. And also on the right side, we have the petrophysical interpretation of this log. Then also another stuff is a petrophysical interpretation for rock physics modeling for reservoir characterization. So when you come up with this petrophysical interpretation, then you can come up with this rock physics template. So in that different templates, we have like QPQS and VPVS and acoustic impedance. So based on that, you can predict also the gas, brine, and you can look at the porosity, the shale volume. So everything you can have. So there will not be only one method we will be using in the course, but also learning a lot of different methods like the inversion, attribute, AVO, rock physics, or geological interpretation. So these are the combination of this course. So I believe this will be a very good course for the people who are interested in prospect maturation. So again, if you look at the concept of the flay of the prospect, so from the basin point of view, so in the basin, there is not only one play. So there are multiple plays in that basin. So let's say this is one play, one second play, third play. When we come into one play, which come from here to here, so in one play, we have a different prospect. Let's say this comes as a region. Let's say if you have a big field, not field, maybe North Sea, let's say. So in North Sea, there is a basin, and in that basin, we can have multiple prospects. But let's say from that prospect, we come up with one play. Then from that play, we come up with the one prospect. And from that prospect, we can find the discovery, and we can name that as a field. So that is a concept of the play prospect. And also some regional section from the seismic. So it's from Borneo Basin. So which give indication of the stratigraphic framework. So not only the structural reservoirs are important, but the stratigraphic features or stratigraphic understanding is also good. So in the top figure, you can see this is a seismic, and on the top of that, the geological or the geophysical interpretation has been done. So in that case has been identified different on labs, top labs, and stratigraphic features. So if you look at the bottom one, so it is actually the drilled one. So you can see this yellow is all your sand, and you can see the connectivity of your reservoir from source to reservoir. So it makes more complicated your field if you have something like that. So that's why you have to be very sure about the information or the methods which you have been learning. So that's why you can apply different way to understand your prospect. So one of the main objective is actually to find the velocity. Velocity is always the main component of the anything, because velocity, when you're doing the seismic stuff, So seismic is also based on the travel time and also the velocity. So if you have the perfect velocity, then you can only go for better prospect maturation, because the velocity can be used for seismic processing, then also mapping in depth. Because let's say if you have find out the best prospect and you have the best methods to verify that prospect, but the velocity information was wrong, and it's not wrong, maybe it's like plus minus 10 meters or 20 meters different. When you give the drilling point at the specific point, but the depth of the prospect is not accurate, then probably you will miss out. So that's why I say the velocity is very important. Then rock fluid prediction, like well placement and drilling, that's what I was mentioning right now. And also the logs, cores, VSP, and check shot, that will also help the post well appraisals and seismic survey planning, because based on the subsurface velocity, then you can define the seismic survey as well, which is about the acquisition. So the velocity is actually the key for everything. When you are a geophysicist, you have to be very sure about the velocity. So that comes normally from the velocity analysis and also from the well logs and also from the seismic inversion. So sometimes the seismic inversion can give you a best velocity, but it's using the well logs. So that's why if we have the wells, so we can correlate our seismic from the well. So if it is following that trend, then it means your velocity is perfectly right. So, so the summary is that, is there any workflow for the prospect maturation using AI? So the answer is no. So there is no specific workflow for the prospect maturation. So that's what we have done in this 2-day workshop. So it's not we will be following this workflow or that workflow, but in prospect maturation, we have to look in a different way. I mean, you have to do the geological analysis, you have to do the basin studies, then we have to apply some data conditioning for seismic. It's called reprocessing or maybe processing the seismic. And also we have to do the attribute analysis. Then we have to come up with these subsurface models on the, then we have to look at the petroleum system. It's a lot of things we have. So in each steps, the AI is a very important part. So when we are doing the seismic interpretation, then we'll be using AI. And let's say if you have the attributes come up with this seismic data, then you take the property of that seismic attribute and bring into the codings. Then you can apply the machine learning approach to predict the better connectivity or the hydrocarbon or anything. Also, we have looked at the AVU analysis, which actually gives you the indication of the prospect. Either it's a gas sand, reservoir sand, or any other type of sand, or even the AVU can predict this uh, fluid indicator as well. So either it's a gas or either it's a oil, brine, or it's a wet sand. So that is also one of the very good thing which we can include in the prospect maturation. Okay, so with that's all. Thank you so much.